time to wake up. It's time to wake up. It's time to wake up. It's time to wake up.
Please welcome my panelists with me on the stage here. Have a seat, please. So I would like to welcome Julia from DLR, Frankwin from, let me check, WEO Water, Martin from Planet, and Robert from DLR as well. So it's great having you on the stage. Again, a warm applause for our panelists here. So when we think about space, many people at a first think about crazy billionaires like Elon Musk, Jeff Bezos, colonizing Mars, etc. But that's not what we are going to talk about today. Today we want to talk about the opportunities space and space-based services, infrastructure, satellites, and downstream applications provide for more sustainability on Earth. Because space is, as I believe, part of the solution for a greener and more digital future on Earth. And I'm going to start with Julia. I'm going to organize that in a way that we will have 1 or 2 rounds where I'm going to ask some questions. And after that, I would like to participate, that you participate as well, the audience, so that we have a bit of a conversation and not just a talk here on the stage. Julia, you're working with DLR. Tell us a bit, what is DLR and what are you doing, and what's the impact of on sustainability and the green transformation?
Okay. So I'm at DLR. I'm at the Institute for Atmospheric Physics, and I'm a researcher. My specialty is working with satellite measurements of greenhouse gases, specifically carbon dioxide and methane. And so how we can measure them with satellites, and then how we can take these concentration measurements and figure out where fluxes from the surface are. So that's like emissions from human activities, but also to understand the natural carbon cycle. And there's feedbacks with climate change in the natural carbon cycle. And space is great for this. So satellites give us better data coverage than we were able to have from ground-based measurement networks, which we also use. And this kind of in the context of sustainability, this is a really useful tool that holds a lot of promise for emission monitoring. Because through the Paris Agreement, countries are trying to reach certain emission goals. And it's generally a bookkeeping approach. You kind of count up all of your activities and there's emission factors. But the atmosphere tells the truth. The atmosphere integrates all of it. And if we don't see the same information coming in the atmosphere as is reported, this is a useful piece of information that tells us maybe we have to check our reporting and see if we're actually meeting the emission goals that we're setting. So it's kind of to contribute to support national emission inventories.
Okay, great, excellent. Very interesting. Frankwin, you are the head of development of WEO Water. What the hell are you doing?
Yeah, I'm happy to tell you. Let me first say that I'm very happy to be here today in a sunny Berlin. I live in Belgium and we have a lot of rain now, so it's a nice change. And also, let me just express my gratitude to be part of this panel. A panel, Spacetech Driving Green Change, that is actually very close to what WEO is doing. So WEO is a Luxembourg-based startup, and we are leveraging satellite data and other sources of remote sensing and AI to make maps and indicators that help our clients in their environmental management. So as head of development, I'm overseeing the development of the artificial intelligence, the machine learning models. And I think there's a very great synergy between remote sensing and AI that basically comes with the 2 major trends in these 2 areas. So at one hand, we saw that the cost of launching satellites into space reduced by a lot in the last decade, mainly because satellites and their sensors have become much smaller. And that led to a lot of commercial launches. Actually, in recent years, the commercial satellites in space, in orbit, outnumber the public satellites. And that means that there's a lot more data available. And on the other hand, there's this trend of AI that can't be missed. And also in machine learning and in computer vision, the domain that I'm active in, there has been an enormous evolution in both the model side, but also, of course, in the compute capacities, so better and faster GPUs, that allows actually now to analyze this enormous amount of Earth data and provide on a global scale and almost in real time analytics on Earth. And that is what WIO is doing, helping to stimulate greening initiatives.
Wow, very impressive. Thank you very much. Martin, you are with Planet. Your office is kind of right around the corner. Tell us a bit, what is Planet doing? What is your mission?
Yes, so thank you, Matthias, and thank you for having me here. Yeah, so I'm with Planet. Planet is a space company. We are headquartered in San Francisco, the US, but our European headquarter is based here in Berlin. So we have about 250 people here down the road, so to speak, at the Kurfürstendamm, where we control our satellites from. And there's our mission control center. So we operate today more than 200 Earth observation satellites. And those satellites, they circumvent the Earth every day and taking images all the time. And we image the entire landmass of the Earth every day. So that means we have every day an image of every place on Earth, for example, today, yesterday, and the day before. So, and because you can only manage what you can measure, that data set has a lot of significance for our global sustainability transformation, right? Applications of our satellites include, for example, tracking deforestation in real time, down to the individual tree level, for example. That allows to provide transparency into supply chains, sustainable agriculture, or disaster response. Our CEO likes to say, or Will Marshall, yeah, so he's a founder of our company, and he likes to say, we build small aircraft or small spaceships to help us take care of our most important spaceship, the Earth.
Wow, that sounds nice. Robert, you're also with DLR. You're based in Oberpfaffenhofen, right? So what are you doing there?
Thanks a lot for the kind invite to beautiful Berlin. I was coming from Munich, which is next to Oberpfaffenhofen, but for space activities, Oberpfaffenhofen is the place to be, definitely. My role is just not to do science in the large science organization DLR, German Aerospace Center, but to focus on the transfer of science, results, of technologies, of space data, and so on and so forth to the commercial market players, to make really products out of this, to really use and sell these products, and to do, let's say, business relations out of DLR. So this is the other track. But the DLR is not only heavily committed to science, space research, but also to this tech transfer and bring things out of space down to Earth for the, let's say, the good of companies, the good of societies, and the good of us all. And I can't compete with this saying, which is a very nice one. But let's say I do it a little bit smaller. For us, space, it's not a religion, it's a business. Thanks.
Thank you very much. That was also a good one. Julia, if I listen what you four already said here on stage, you could get the impression that space is about data. And how important would you say are these data? You already mentioned CO2 emission tracking and what you can do out of space. But is space nowadays a data business? and how important at a whole are these data?
So space can be lots of things, but of course I work in Earth observation, and yeah, it provides us with data, but data also need to be interpreted. Because really what's usually being measured is an electromagnetic spectrum that doesn't mean anything until it actually is turned into a geophysical product we can understand, whether that's land cover or land cover change, or whether that is, you know, surface moisture or things that we actually are interested in. But yeah, of course, we use this information all the time. Of course, we can't rely on space entirely. There are places where a lot of these methods don't work as well, like when it's persistently cloudy or places where it's very dark for parts of the year. A lot of the methods break down. Not all, but some.
Okay. So you, on the one hand, you have space-based systems who generate a huge amount of data, but the main task then is like interpreting and using this data with AI, for example. Are you using AI technology as well?
We do for some applications. So we kind of started with more classical interpretations. Running atmospheric models actually takes a lot of computation power. And yeah, when you really get down to high resolution measurements in the atmosphere, it's hard to match them exactly because it's a bit chaotic. You know, this is why weather forecasts aren't perfect. And so you kind of get one realization. But if you can train a model on lots of different realizations of what transport could look like, then you can use machine learning algorithms to, you know, recognize plumes and go directly to the emissions, even potentially without knowing the exact wind speed, which is great because that's one of our largest error sources.
Okay, and you're doing that on a, let's say, a global level, or are you focused? I mean, DLR is a German institution for Germany, for Europe. How is your focus?
It depends on the project, depends on the question.
Okay.
Yeah, so sometimes global. Yeah, we do global inverse modeling to kind of get the global carbon budget or methane budget. But sometimes there's national scale. You know, in Germany, there's the ITMS, Integriertes Treibhausgasmonitoring-System. This is a emission monitoring program, sort of through the German national research plan. And then in this case, we're really focused on Germany using higher resolution information. But it depends really on the data that we're using, the resolution available, and what the research question is.
And would you say that the beauty of space and space-generated data is that national borders doesn't matter or don't matter?
I mean, they never really do with geophysical data, but it does make it easier to measure in some places that are harder to do field campaigns, for instance. Like, we're not doing any more field work in Russia right now, but we're still making satellite measurements.
Okay.
Maybe I can add to that. Indeed, borders don't really matter, right? The satellite just measures what's on the surface of the Earth. What we see at WEO is that borders do matter in another way. We try to train artificial intelligence models, and for that we need to also have ground truth data. And the ground truth data can be, for example, land cover types in a certain area, and these are actually still quite restricted to the national borders. So that means that sometimes we can train a model that works very well, for example, in Belgium, but then it's more problematic to also work in a country that has different vegetation like Spain.
Okay, interesting. Thank you very much. Martin, you mentioned you have 200 satellites up there. Do you have some concrete examples how you use them for more sustainability on Earth?
Yeah, so thank you for that question, because there are a lot of use cases. So our data is as we speak today, used by thousands of customers already, right? So I want to share one very predominant and important example, which is Brazil, deforestation in Brazil. So in 2023, tropical deforestation in Brazil of the rainforest decreased by 55%. Again, 55% in 1 year decrease. Question, of course, how did that happen? And the answer is it's directly linked to Planet's data, to our near daily data. So what happened is that in 2022, the Polícia Federal of Brazil introduced or implemented a system for real-time deforestation alerts in the forest. And they rolled this out, the system, to all of Brazil's government. So altogether, we have today 80,000 registered users on that system, 80,000, all of Brazil. And our resolution of our daily constellation is good enough to detect the removal of a single tree in the rainforest. Of course, the tree has to be large enough. We're talking about larger trees, right? But whenever a tree or a group of trees is removed from the rainforest or specifically from protected areas, then the system generates an alert, right? And it goes to all the people who have, let's say, access to the system and so on, right? And the Brazilian law enforcement authorities, they use those alerts to plan and coordinate their operations. Yeah? In addition, the Brazilian government, they changed the judicial system to allow for our images to be evidence in court so they can take legal action from start to finish. Yeah? So I think that's a very encouraging and very important example. And I would like to add a little anecdote. So at the beginning of this year, 2024, a colleague of mine relocated from Europe to Brazil. You know that colleague, it's Agnieszka, yeah? And because she relocated for 6+ months, she needed to go and register whatever with the local authorities, right? So she goes there and to basically apply for all the different papers and so on, right? And the officer asked her, so what do you do? Who do you work for and so on? And she says, Planet. And he looks up and says, like, is it that planet, connected to this project? And she says, yes. And he's like, welcome to Brazil, and stamp given. Yeah?
Okay, so Martin is the man for the anecdotes. He has a lot of interesting stories to tell. Very interesting. Thank you, Martin. Robert, in our briefing we did ahead of this panel, you said new technologies are available and we need to be faster in implementing, in using them. How are you doing that?
How are we doing this? I think important is that we were just listening to the outside world. So to figure out what is maybe a need from a customer or his customers. This might be, for example, a public sector authority has a specific demand for data, for add value products based on Earth observation data. And we get this request and think it over. How could we, let's say, come together with them in a technology push and market pull combination? And therefore, we just can do so-called innovation projects and act as an in-house investor. So we have a budget, which is attractive also internally, to leverage the application readiness level and come closer to the product or the requirements of the customer. And then we need to find a so-called best owner. This is a company. Sometimes it's a startup company, sometimes it's an established larger industry company, and sometimes it's even also an own spin-off. And for us, this has no different color. We like to cooperate with all these companies, but the important thing is the execution. And we make license contracts with those companies, and they have to promise, so to say, that they really don't make a product out of this and bring this to the market and scale it. And of course, I think you can read between the lines. There are always these digital offenders in startup companies who are very busy and very creative and very powerful and agile in let's say, developing and executing new products. So therefore, I warmly welcome this NewSpace initiative, because there these companies get, let's say, the push and also the visibility and management attendance They just don't do business only, but they also provide new value and let's say contribute to the progress. And that's how we just bring research results like data, like software to process big data to the market, mostly in a kind of value chain or a value network. That's our way to do the tech transfer.
So you mentioned startups, and you're working for a government institutions. So I guess you're also very agile and how government institutions are. So how is it working together with startups? Is that always going very smooth, or are there also some minor challenges?
Okay, you mean the bumpy road to market. So first of all, I have to comment, we are not a government organization, but we are a public organization.
Okay.
Which the NASA, the administration is the second A in NASA. They are really in administration, and we are just the basic funding is public, but it comes from the government. But you can compare it to the public television, for example. If we just cooperate with small companies, no matter if it's own companies or if it's external companies, we have to treat them all the same. That's for sure. Normally, the people are hyper committed to what they do. And sometimes they love their own topic, they did their own research on this, and now they have to license this technology. They just develop themselves within this large research organization. And sometimes you have to explain this, okay, that we need a kind of regular contract, and it's not a donation, but it's a value they get, sometimes even an exclusive value. And if they make money and make good bargain and generate profit with these new technologies deriving from DLR, we expect a kind of payback, a share. But it's not a share in, let's say, the company, it's only a share in the money they earn with the product. And it's always a negotiation, but I don't remember any case where we could not get along with this. And to be honest, the larger corporations and so-called large system integrators, how it's called in aerospace, they also bargain, and you also have to negotiate with them. They maybe have more money, but they don't show it. So I think life is the same for all of us.
Okay, interesting. Julia, you're also with DLR. In your field, do you also cooperate with startups?
No. Not really.
Okay.
Yeah, I mean, we've had some contact with some private space companies, but actually we're doing more fundamental research.
Okay.
We're developing missions, actually, like national missions and European missions for public data, which also has trickle-down effects. I mean, for using free Sentinel data for companies like yours. And this is
Can
actually...
you give us an example?
So Sentinel-2 data are being used by his project.
Okay.
But in terms of the projects that I'm working on, I mean, on the national level, at our institute, we have the Merlin mission. This is to measure LiDAR with lasers so that you can actually measure LiDAR in the Arctic, also in the winter, because this is... If they're thawing permafrost, we can't see it with some of the satellites we have now because they need sunlight. And they need sunlight off of reflective ground, which is not ice or snow. And so we're actually providing, new technologies to monitor aspects of the climate that can't be done right now. And this is fundamental research. And I mean, this is a national mission between Germany, so the German Space Agency, DLR, and the French Space Agency. We've developed a mission concept for emission monitoring also at DLR, and we were working with also private industry. We always work with industry. The industry still gets money because they still build parts of the satellite, so it's not like they're not getting any money from it. But what's key is then the data are also public. And this is important because if you're using this for something as important as emissions monitoring and you want to use this in national emissions reporting, it has to be traceable, it has to be transparent. And when everything is a proprietary algorithm, you kind of lose this transparency.
Okay.
So, yeah.
So all of your data is public?
Yes.
Okay.
This is also a bit of a philosophical choice of projects I choose to participate in. I don't
Okay.
work on defense projects, and I work with public data because we are paid with public data, or public money, yeah. So we're paid by the government, and we're making science for society.
And would you say the quality of the data provided by satellites and space-based systems increased in the last couple of years? And where do you think, where will we be in like 5 or 10 years with the space-based data? Will it be significantly better than it is today?
So definitely things have improved. I can speak mostly to my field, but certainly the sensors have improved. We have better detectors. So we actually have, this is part of why we can have higher spatial resolution. There are some fundamental physical limits though, like there's only so many photons being reflected off the Earth, so we can't necessarily make more signal where there's only so much light. But yeah, the technology improves, and also our interpretation of it, how we can retrieve the information we want from what we're measuring, is improving all the time.
Okay, great. Frankwin, do you want to add something? I mean, you are using Julia's data.
We are using the Sentinel data indeed. So we're mostly using open source data. Open source data is great. The ESA, European Space Agency, has the Copernicus program with a lot of Sentinels orbiting the Earth. They catched up with the NASA program. NASA was there before. They started in 1970. You're black behind, but I think they catched up, and they probably have now the top class Earth observation program in the world.
Okay.
So we use this data. And we are a downstream company, right? So we use the data and we add onto that. We also have this philosophy of using open source data. One, because it is globally available, it has high revisits time, so we can have a lot of frequent updates for our clients. And we do different services based for different clients. And maybe one thing that I can speak about is what we do for cities. So the cities have been amongst our earliest clients in Luxembourg. And we help cities cope with climate change, adapt to climate change. So probably all of us here heard about the urban heat island effect. So the fact that cities are significantly warmer than the surrounding rural areas, up to a few degrees, and even more so during the night. And this means that cities also have to cope, and they're more vulnerable with heat waves that are increasing both in frequency and in intensity. And actually, cities are aware of it, and they want to try to reduce this effect by cooling down the cities. And one effective way is by greening their cities. So cities have been pledging to have more canopy cover, more trees, in the coming years, right? So Paris, for example, by 2030, they want to have 50% canopy cover. Berlin is doing already pretty good with 30% canopy cover currently, but they're also monitoring. And in Luxembourg, where we are based, there's something like the Natuurpact, and they state that cities that take part also need to strive for 30% canopy cover. So what WEO does is that they help monitor over time this canopy cover, the green spaces in the cities, so parks, but also private gardens, green roofs. We inventorize green roofs existing, but also the potential for new green roofs. And we also look at the health of these trees, right? So that we can help them manage their urban green spaces. And another thing is that we look at the land surface temperature in these cities, day and night, so they can correlate that to whatever land cover classes are in their cities, but also, for example, neighborhoods with more trees, are they effectively cooling down? So that is one thing that trees does, but trees also, of course, look for cleaning air. Their general affect the well-being of the citizens, and they also help in the water cycle of cities by evapotranspiration. And that's another thing. We know that when Earth is warming up, warmer air contains more water, so cities are also increasingly worried about floods. And we help them in managing their floods, for example, by looking at sealed surfaces in their city. So this is a variety of services that we offer, and again, the nice thing is that because we use satellite data, we can do a very fair, consistent comparison between cities within the country, but even go as far as within Europe or even extend Europe and compare between cities. So I think this is what is very interesting for our clients.
And your clients, they are mainly cities, local governments. Do you also have like private customers, or is it, let's say, government institutions mainly?
So we only started recently, and we have now the main cities in Luxembourg, the major cities in Luxembourg subscribed. Also the environmental agency at the national level is subscribed. But we also start to get some private clients now. For example, for linear asset management, the CFL, that is the railroads of Luxembourg, they are subscribing to us because they want to prioritize their management of trees that form a risk falling on the tracks. And so we start to also get into this sector now, but it's a development.
Okay. And you mentioned that you're using public available data. Is that enough? Are you also, let's say, purchasing additional data, like from Martin from Planet?
So we have been speaking to Planet, and we do occasionally buy commercial data. Of course, commercial data is much more expensive, and the setback of open source data, I think, and Martin could agree with this, is that the spatial resolution is typically lower. So for Sentinel-2, for example, a source of visible remote sense data, that is 10 meter. So it's a square of 10 by 10 meter on Earth. And we are looking at individual trees. So we do definitely need to enhance this data.
Okay.
That is part of the algorithms that we built, and we can now look at individual trees using this data. But we do need to have a starting point. The starting point can be open source data like aerial photos. But in some cases, last year we did a project with Brussels, and there we needed to acquire commercial data.
Okay. Martin, are you too expensive?
Well, I mean, we are a lot more expensive than €0, right? So from that perspective, yes, mathematically speaking, right? So relatively speaking to the use case and the outcomes and so on, that's a totally different story, and we're growing our business. But I want to highlight one thing, which is almost 100% of our customers have started using public data, namely Sentinel-2, the data source that you are using, and I would say the majority of the users of Sentinel-2 at some point in time come to us. This is when they need higher spatial resolution or higher temporal resolution, right? So I think you mentioned already the publicly available data that is closest to what we do is 10 meter per pixel, so 10 by 10, this is 100 square meters, right? Whereas our resolution, with which we image the entire landmass of the Earth every day, is about 3 by 3 meter, right? So let's call it 10 square meters, 1 pixel, right? So that means on the spatial domain, you have about 10 times more information in our data compared to the Sentinel data, right? So, and again, it costs money, and for many use cases, 10 by 10 meters like Sentinel is good enough, and no need for any other data. But there are tons of use cases, like for example, individual tree loss in a forest, right? If you want to detect that in real time, so to speak, they come to us, right? So, secondly, these temporal resolution, Sentinel-2, it has at the equator a revisit of about every 5 days, right? Every 5 days, one image. If you have a cloud, which is quite often the case at the equator, you need to wait another 5 days and something, right? So, whereas we image every day, so in other words, even if there's a cloud today, we try tomorrow, right? And not in 5 days. So you have about 5 times more data on the temporal domain, right? And then one last but not least thing, we use extensively Sentinel-2 or public data. It is, from a scientific perspective, It is like absolutely high-end Sentinel-2 data. So, and we operate like 200 satellites, right? And we need to make them all look like, radiometrically, like from a measurement perspective, as if it is one sensor, right? How do we do that? We cross-calibrate to Sentinel-2, which is our scientific reference. So it's a very important element.
Maybe can you add 2 sentences about what is Sentinel?
Yes, sorry. So Sentinel-2, or the family of Sentinel satellites, it's a constellation of satellites operated by and funded by the European Union. And you're right. So optical sentinels, I mean, there are different types of sentinels, right? So there are ones that take optical images, let's say visible images, right? But then you have other sentinels that, for example, do radar data, right? So they measure elevation, for example, right? Or you have other sentinels that measure, for example, the atmosphere and so on, right? So this is a larger family of satellites, and again, 2 out of the large family are very similar to what we do, with the differences that I just described.
And is there somehow a competition between you and Sentinel? Is that going along well? I mean, you depend on, let's say, selling your data. You have your own satellites, and the EU project is providing the data, let's say, to everybody. How is that working?
So, I mean, it's a very good point. And at the surface, you could say that the free public data, it eliminates part of our business, right? But in reality, this free public data allows anyone with very low hurdle, or actually 0 hurdle, to start playing around with satellite data. Yeah, and as I mentioned before, all our customers, with no exception, they have started with free and open Sentinel data. Didn't cost anything. They tried out, no risk, nothing. They gain enough experience to understand where and for what purpose they use, or they could use higher resolution data, right, which is not free of charge. And when they come to us, they are already educated. They know exactly for what purpose they need our data, and they have a business case. So it actually makes our life easier.
Okay. Robert, do you want to jump in? Want to say something?
Yeah, welcome. But I'd like to also draw the attention on the connection of remote sensing data, satellite images, to some few very interesting other constellations we also have in the space domain. It's about satellite navigation, it's about satellite communication, it's about control of autonomous systems like robots, for example. And therefore, I'd like also to do the little bit connect from this, let's say, spatial information and information extraction to, let's say, business processes, like in logistics, to track assets, to track trucks, to optimize, let's say, travel routes, to better understand also the insurance business with a, let's say, a higher level of process and workflow integration of this space-derived data in business processes. I think this is also a very important thing, because we as, let's say, space guys, we always think, okay, that's the perfect product, take it and do whatever you like, and tomorrow I make another perfect product out of what I master. But in the real life, we learn so much from our customers from different sectors and very different domains, and they very often they need this integration with other solutions down to earth. May it be also terrestrial mobile communication or whatever, or existing statistic data. And they also need to have this in systems in a higher level of integration, maybe like a warning system, like SAP, and boring stuff, but very valuable for the business. And I think if we talk about the, let's say, available Earth observation data, there it's very rich. It's never been so good, and it's really breakthrough by Copernicus Sentinels. I totally sympathize with this, but now it's more about, let's say, bringing this in the last corner of every company and business. And I think this is the big leverage. And let me give you 2 examples also to really carry on action. So we just developed a system where we use Earth observation data from pollution data from Sentinel-5P precursor to better control cars in hotspots of air pollution. To really control, let's say, the combustion engine and optimize the operation of cars, for example. And then you just, let's say, lower the emission footprint and make maybe also the car, let's say, not CO2 neutral if it's a car with a motor engine, but to make it more smooth. And this shows, okay, it's not only about knowing, but also about integrating this knowledge in real time, in a fleet, in a business. And I think this is also, let's say, maybe the next big thing for us all. But therefore, we need customers, we need to understand what they want to do with this data, and not so much talk about ourselves.
What about autonomous driving? Do you need space-based data for that?
Definitely you can't execute this without space-based data if it's HD maps, very high definition maps with all the lines and everything updated day by day. You also need precision navigation. You need to operate these cars on an optical tunnel like a robot, which is also a strong discipline in space research. And without all this knowledge, you end like some other companies who say, okay, we can drive completely autonomous, and then at the next corner or at the next red traffic light, they get a hiccup. So, of course, you need this, and otherwise it will not work. And let's say the reason behind is you always need redundancy. You need redundancy, like in an aircraft. Nobody would fly with an aircraft which has only one system on board, because this is much too risky. And for an autonomous car in a high level, starting from level 3, going to level 4 and 5, without redundancy, without connectivity, without space data, and all these domains of information and also integration, this will not work. Therefore, it's not just let's say nice to have. It's not goodwill that the automotive guys ask us, but it's an absolute, let's say, life insurance for them to have space data applications and infrastructures which are really working. And therefore, I think Europe has made a good job in the last years. Europe and Germany.
Okay. And would you say that the non-space actors are already full aware of the potential of space-based data and the opportunities and how that these data can help them with their non-space business cases? Or do they need some more information, or are they skeptical? So tell us a bit about that.
Of course, maybe we as, let's say, space business are sometimes too reluctant. And sometimes, okay, the world is turning quite fast. And as an eye-opener, I much appreciate what Jeff Bezos and especially Elon Musk do, because they made this big business out of space. And they showed, okay, they could really do everything they want with their money, but they just focused on these activities. There must be some, let's say, some magic in business terms, but also fascination in technology. And of course, the only thing we can do is just talk and get in exchange with anyone who is just interested in the future and wants to improve his own business. And my conviction is just the real innovation always happens at the interfaces. You have to get in touch. And that's why I so highly appreciate that I'm invited here and can also tell a few words about DLR in research, but also DLR as a provider of space technology to let's say, foster a make or buy decision on this.
Mm-hmm. Do you agree with your
I'm not
fellow
sure.
DLR
I'm not sure
colleague?
of which part I'm supposed to agree. I would actually say that all businesses are already using space data all the time and just take it for granted, because not the new space maybe, but the old space. Like, who doesn't use GPS for something? Who doesn't use weather forecasts for something? This is all based on space data.
Yeah.
And some of this is new and innovative data. So actually, also DLR was very involved in Aeolus, which was a wind LiDAR that launched, I don't know, 5, 6, 7 years ago. And it was incredible. This was funded by the European Space Agency. And this is like a wind Doppler LiDAR, so a laser in space that can actually measure wind profiles. And it like revolutionized weather forecasting. And this is, again, a public mission that's used by weather services around the world, and this is making everybody's weather forecast better. And weather is important to so many businesses and so many ranges, and agriculture, and for planning, and like what's it not important for you know, infrastructure monitoring. And so I think as new domains of space data get more mature, they will become also so completely something you take for granted. Of course, we can do this based on satellite data. Yeah. Okay.
We've got 15 more minutes, and I would now like to open the discussion to the audience. Are there any questions for our great panelists up here? Yeah, there is one. May I borrow that for a second? Say one sentence.
Test.
Whom you are with, and who shall answer your question?
Sure. My name is Paul Seethoff. I'm a journalist for Greenworks. We're a magazine working on sustainability. So my question is directed at Martin. So I recently wrote some articles about the REDD, like red market and carbon credits. Maybe not only to Martin, but do any of you work with carbon credit companies, and it's like monitoring rainforest data? Like, are there companies approaching you that want to work with you? Yeah, thanks.
Yeah, so since you mentioned my name, I'll start with an answer. So the short answer is yes, absolutely. We, based on our global data set, 3 meter daily, we are developing right now a carbon measurement product. So basically, we have released one already with a lower resolution, but we will, mid this year, release another product, 3 meter, quarterly updates with basically above ground carbon measurements. And yes, that is relevant for a number of market players. So some are, of course, the owners of forests. You know, these are governments, these are states, or companies, and so on. So or basically anyone involved in trading or in the matters of carbon credits, they are probably interested in that product.
If I can add to that, we were also asked by an organization called the Open Forest Protocol to actually look at and check their data on trees. It was also in the Amazon rainforest. So it's a logical extension of our services. We do trees in mostly urban areas. So we are actually looking into this now as well.
Who's next?
Hi. Yeah, thank you for the discussion. My question is to the overall panel about the interoperability of the different sources of data that we work with. We discussed the different sources around Sentinel. If I have access to DLR, access to Planet, how easy is it, or what are the challenges that I can foresee if I have to combine access to this data to derive much better insights, which I might not get from just one source?
So maybe I can start off. So indeed, you can very often combine different sources. So I agreed with much what Martin said about using Sentinel versus Planet data. And one thing we can do as well is combine these sources. There are always small differences. So for example, in remote sensing data, you typically have more bands than just your red, green, and blue. this extends in the electromagnetic spectrum, in the infrared and the shortwave infrared. And not all different sensors have exactly the same bandwidth on all of these same parts in the electromagnetic spectrum. So there is ways, to a certain extent, to fuse this data. But another way to tackle this, and that is what we do at WIO as well, is to train our models on different sources of data, so that the model itself is robust against the source of the data.
I would like to take the ball from you, so to speak. So you mentioned it is possible to fuse data. Coincidentally, we have a product which is called Planet Fusion, which is a fusion of Sentinel data and our data, near daily data, together. So the idea is that you, as a developer, for example, or someone who wants to use space data, you don't have to develop your application anymore for a specific data source, right? But that you can basically, if you have developed an application for Sentinel, and then you come to us, you can basically swap out, and your application works out of the box just with higher resolution, spatial and temporal from our data.
Out of the box. Question?
This question is for Julia. Which missions are you most excited about that are going to be launching in the next years, perhaps particularly in regards to climate change?
So I'm biased, of course, right? But I'm involved in the development of CO2M, which is a CO2 anthropogenic emission monitoring mission from Copernicus. So this is an ESA and European Union co-production, so to say. And this is really being built up to develop a Copernicus CO2 monitoring service. And so we've actually had a variety of projects over several years now, working on developing this. And it's called CO2M, but it also measures methane. And I'm quite excited, but this is at 2 kilometer resolution, and it's also measuring NO2, which is great for seeing combustion point sources. And I think this is really going to give us a whole nother aspect of data, but we also know it's not enough. So this resolution was chosen so that it could also get global coverage. And there's going to be 3 satellites now. We've just found out a few months ago that the 3rd one's going to be funded, which is exciting. And so for me, this is really game changing. But we're also working on, a mission at DLR to have a higher resolution kind of zoom version of a similar measurement that can then, for regions where we need better than 2 kilometer resolution, go in so we can actually separate individual point sources. And I think this is going to be a really powerful tool for emission monitoring. But yeah, CO2M.
This is also a question for Julia, but I think related as well to the fusion ideas. And just the thought of how close do all the different monitors line up? Like if you look in one versus looking in another, is there this gap where one might show something versus another? And how much do you rely on just the source that's the open source, or do you go into the other monitors to look and check and see if that's really there? So
I can only answer kind of from my experience, and so I mostly work in the atmosphere, but I use the surface measurements to sometimes to run models or as a proxy for sort of an idea of the spatial patterns of surface processes. And we've experienced going from kind of what was our workhorse for years for this was MODIS, and this was comparatively coarse. This was a NASA product, but we have 20 years of free, great data. And then switching to Sentinel-2. And this was kind of there's just the logistical problems of the data are suddenly a lot bigger. Higher resolution means a lot more storage, and trying to compare them and seeing how comparable they are. Normally, there's a lot of research done on this also to characterize it. And so we don't see complete surprises, but it's something that you have to look at and be very careful. So in an operational setting, you would always, before just switching products, monitor it for a long time, sort of run it and say, okay, do we understand the differences before saying, yeah, okay, we can actually use this as our main source for this. But I guess you've probably done similar, yeah?
No, I think it comes back to the question that was asked before, and indeed, we experience that the differences are not very big, and in most cases, there are even, when it comes to open source data, again, already products available that did the fusion. For example, Landsat and the Sentinel program, the NASA and the ESA program, typically they have already fused data.
Additional question from the journalist. Don't be too critical.
No, it's more of a personal question. I'm just curious. Julia, will weather data get like way more precise in the next 5 to 10 years if you say, for example, a leader is helping with wind, then I could imagine like everything else will become more precise as well?
It would be great. So we can hope, right? And I'm not going to say it's going to be perfect, but definitely things are improving. So Aeolus is actually just stopped, but they're already planning like the next 2 Aeoluses because the Weather Service has said this is that important and it is really improving things. We also have, really next generation geostationary satellites. So like there's kind of the one that sits over Africa and Europe and another that sits over a series that sit over the Americas and over Asia. And we're actually pretty good about sharing data between countries and between agencies with these things. There are some innovative products, but weather's tricky, right? Because it is a chaotic system, and so if you don't get the initial conditions exactly perfect, it's always going to branch off. But if you look at how much better, I mean, nobody feels this. Everybody says, oh, the weather, it's always wrong. But we can actually measurably say that the weather forecasts have improved dramatically over the past 20 years. And there will be a limit probably for how much this can improve, but the spatial resolution of the models is improving. We're actually able to really simulate processes that before were fully parameterized. And so, yeah, actually, I think it's going to get better. Not perfect, but better.
Question?
No, it's okay.
Thank you. I have 2 questions, a simple one and the second one for you, Julia, again. Planet Work so far is, Planet Lab, sorry, you said that it was a 3x3. Are there greater resolution technologies out there? That was one question. And the question for you, Julia, is when you said you were working on methane and CO2, and so with that technology, are you able to identify methane leaks, let's say, from fracking industries and be able to report that?
Yeah, so I'll go first. So thank you for your question. On the resolution classes, let's say, the majority of our satellites are 3-meter resolution satellites, right? But we have a second constellation, which is 50 centimeter per pixel. We have 21 of those. And we will launch a new generation of high-resolution satellites that will be in the range of 30 to 40 centimeter per pixel resolution. Yeah, I will answer part of your question that was directed to Julia. She's smiling because she knows what I'm going to say. Because Planet is about to launch a new constellation of satellites focused on methane leak monitoring, point source emitter monitoring, right? And just for everyone else here, so methane is a very powerful greenhouse gas. It is about 80 to 90 times more powerful than CO2 over a period of 20 years, right? So 80 to 90 times more powerful. So even smaller amounts have a very detrimental effect on the climate, right, in the short term. So basically, the constellations of satellites we are bringing to space will allow us to measure point emitters of methane. The problem with methane is that it is completely invisible and odorless. So it's really hard to detect until you have a satellite, that can do it at scale, right? So, and back to what I said earlier, it's impossible to manage what you can see. So that's a change that we will do, right? So suddenly, with that constellation, it will be we will be able to visualize the emissions, and that transparency will help actors, basically in the oil and gas industry, to take action, but also at the same time, the transparency may increase the pressure on them to actually act.
And I would add something to that because there are a few sensors that can do this. Actually, one of the first was the first kind of big private greenhouse gas company, GHGSat. It's a Canadian company that has, I think, 9 or maybe now 11 sensors on orbit. They've been doing it now for more than 10 years. And their data aren't public, but they do have sort of a third-party status with ESA, so every now and then we get to kind of look at some of it, but it's not super transparent. But they do this. They're measuring this, and they sell their data. Their customers are oil and gas producers who get their facilities monitored. And they've really shown that it can be done. They use kind of an interesting technique. I'm not going to get into the technique. So this definitely is done. So the sensor that's going to be launching there, Carbon Mapper, this is working in the same idea. We also have hyperspectral sensors on orbit that we know can do this. So NMAP, which is a DLR instrument, you can retrieve it from this. What's it called? The NASA sensor, EMIT. That was actually originally to measure mineral dust. They realized, hey, we can also retrieve methane from this. If you have a big enough plume, there's a big enough signal there. And these data are already being really pretty well fed into something called EMEA, the International Methane Emission Observatory, which is a program of the UN Environment, UNEP, protection? I'm not sure. UNEP, whatever UNEP stands for. So they have this program that's actually doing exactly this. So they have this online system where when a satellite picks up a high methane signal, and they have scientists that are actually scanning it, and they have algorithms searching, also even in Sentinel-2 data. If you have a big enough plume, you can see it there. And they will say what facility is this, contact the facility and say, we think you've got a leak. And this is actually being done in a fairly semi-automated operational way as an effort to reduce methane emissions, because as he said, it's the low-hanging fruit. Not only does it vary a strong greenhouse gas, but if we stop emitting methane, okay, we're not going to stop, but let's say we stopped emitting methane now, it actually goes down because it has a 10-year lifetime in the atmosphere. So it will actually reduce its climate impact. If we stop emitting carbon dioxide, we still have way too much carbon dioxide in the atmosphere because it stays there for a really long time. So methane is an easier thing to get fast climate action, but there's no getting around fixing the CO2 problem.
Okay. It's 3:30 in the German capital. This session is coming to an end. Thank you very much, Julia, Frankwin, Martin, and Robert. Please give our panel a warm round of applause.
It's time to wake up.